Okay, guys, let's begin the race. All right, guys, let's start and walk through. Now, I'm working with the questions you guys sent. So I don't have questions of my own. Okay, I think I added just one or two. All right. And for this particular session, I'm just going to be the one working mostly because I believe you've walked through some of the questions and you're just sending me what you found challenging. Okay. Starting with this one. And some of you would give me a question 9.3.2, but there's no way I can do 9.3.2. I want to cascade down. So I also see the flow. So we have electrodynamics. So I'm going to try to touch every question that was sent. I'm going to try. It was a lot. It was a lot. Okay, quickly. And while we do that, we also revise. Whatever question you can also answer just before I do, please go ahead and answer. Study the diagram of a simple what? Generator. The first thing is this an AC or a DC? This is an AC generator. And the question would be, why is it an AC generator? Okay, let's talk about what is present. What is present here that's making it an AC? What makes it an AC are these slip rings. Okay, so let those answers come in as quickly as possible. Beautiful. Thank you, Linda Kutley. Guys, I don't need to call anybody, but let the answers come in. Whatever I say, just type in, unmute yourself, respond. These are slip what? Rings. And that would be a reason for your answer. Done. What is the energy conversion here? So we are producing. Okay, somebody quickly answer that. Let's see. What is the energy conversion? So these are basic, your 1-2 marks that you need to get quickly. What is the conversion here? Oh, beautiful. Thank you. Mechanical energy to electrical energy. Please make sure you put the word energy there. Electrical what? Energy. Lovely. So in which direction will the induced current flow? Remember, this is a generator. So what are we using? We're using the right hand. For generators, right hand. If it's a motor, left hand. All right. So the question is, I hope you remember, we had to use our camera the last time. You answer this question and see, let's see what you would be saying, and you'll compare with mine. Try to answer quickly. You're using your right hand. Your thumb is pointing up. Your first finger is pointing to the south. And your second finger, we're looking for the direction of current. So you put your hand by the north. And we are told it's clockwise. So my thumb is pointing up. So, and my second finger will be pointing in. So it should move from A to B. Did you guys get A to B? Let's see. Did you all get A to B? I need to bring my laptop so that if I need to. But did you get A to B? Okay. Lovely. If there's anybody who's confused about that, please just probably inbox me later. Maybe I can do a little, hold the question paper and do a little recording just for you to see. But so far, so good. Looks as if everybody is good. Yes. And then the current. That's all. All right, let's look at this. Who asked me this question? I think it's you, Sarah, and I think okay, she'll see. The diagram below shows the EMF versus time. Okay, definitely we know this is E maximum, V maximum, right? Calculate the resistance of the load if the IRMS is 4,55A. Please, it's always important. If you write the things you know, it's going to be very easy. What do I have? I have IRMS, right? What's my IRMS? 4.55 amps. But I know the Vmax. What is my Vmax? 150. Now I'm looking for resistance. That's basic Ohm's law. V equals to what? I. But here is the problem. This has to be what? RMS. I cannot use Vmax and IRMS. I have to use RMS across.
Oh yeah, and this is the only please over root something.
Yes. So my VRMS, if we check our formula page, is V maximum over what? Root 2, which is what? 150. Lovely. Can I bring that there? So can I bring that there now? What would that be? 150 over what? Root 2. Do I know IRMS?
Yes.
4.55 times what? R. Is it the math? 23.31 ohms. Can you please do the calculation and let me know if we agree? Once you write the things you know what you need, then life becomes a bit easy. Calculations are not very hectic. We just throw them into the formula and we are done. Are we getting the same answer? Please let's confirm. All right, thank you. We agree with that answer. So please don't let the calculation, things like this, just take your marks away. Write everything you are given and then walk through. You will be fine. All right. Also, our next question. The load RL is now replaced with a bulb with a power consumption of what? 400 watt. So that's the power. Assume that the bulb is what? 100% effective and calculate the light energy emitted by the bulb in 3 minutes. What are we looking for? We're looking for what? The light energy. We're looking for energy. When we say energy, it's just basic work. All right? Now, how do we calculate energy? Again, your formulas will tell you. Let me quickly create a formula, a new page here. So we're doing 9.5.
So we're looking for W.
Calculate the light energy. No. Yeah, we're looking for W, which is work. Now, what do we know? Our formula is P equals to W over what? Delta T. Now, this is what we're looking for. We're looking for work, which is the same thing as what? Energy. Let's go back to the question. We are told the bulb is 100% what? Effective. And the power consumption is what? 400. Already I know power. 400 equals to, this is my work. What is my time? 3 times 60. 72,000 what? Joules of energy. We are done. We move to the next one.
So then E, what is E?
E is something as energy. So this is also E. Work is the same thing as energy. And we are done there. So once we know your symbols, formula, please use your formula page. Don't try to write it from your head. I hope everybody's okay there. The speed of rotation is now doubled. What will happen?
It's going to get there's more graphs within the time.
Number one, more graphs. Number two, the current will also what? Increase.
Yeah.
And not just increase, it will actually double. We'll redraw the what? Above diagram in your answer book on the same set of axes. Indicate the old and the new pattern obtained. So if I double, I'm going to have this. And this should be what? Now you will notice it's two complete waves now instead of what? One complete wave. With which factor will the energy, I love this. With which factor will the energy emitted change if the speed of the rotation is doubled? With which factor will the what? Energy. Okay, hold on. When we say energy, remember, which is also the same thing as what? Work. All right. What have we done here? Do you notice that we have increased the voltage? Okay. What is the formula for voltage regarding energy? Okay, look at this. One formula you would see, let me take you to how they got the formula so that you can see that, right? So the energy, which is the work, is what? Power times what? Delta T. But this power can be written as what? V squared over what? R delta T. That formula exists on the formula page. Why am I thinking of this? I do have a resistance, which is constant. What happens to the time? Okay, but what happens to the voltage? Voltage is doubled. Okay, how will that affect W? My new voltage is 2V squared. So what would that be? 4V squared delta T over what? R. What do you notice here? What do you notice here? That's the old W. So if I like to put W new here. So what is W new? It is 4W what? Old. By what factor? 4. By a factor of 4. How are you? Guys, are we okay? Did it make sense? By a factor of 4. This you will find again in multiple choice. It's present in multiple choice a lot. So it's about the formula usage. Formula usage. Yes, talk to me. Yeah.
So how did you get from W is equal to 2V squared delta T over R to the next? How do you move from the first formula to the second one that you?
All right. Look at the diagram that I have on the board. It says by what factor will the energy change if the speed of the rotation is doubled? Remember, we doubled the speed here, and when I double the speed, current will also what? Double. So my new, you notice my new V here is what? 300, and it was 150 before. So it's 2 times. So whatever the value of V is here, when I double it, it becomes what? 2V.
Okay.
Yes, and then you just expand 4V squared, and this is W.
Oh, I get what you mean. Okay.
All right. That we must expect. We're going to use that a lot, a lot, a lot. Okay. So 4V there. Beautiful. Oh, please answer this one for me. This is my question. Multiple choice. This is my question. Those of you on YouTube, you can also send in if you have any questions on. Oh, wait, I'm seeing a comment here. Okay, I need to go get my tab so I can see what's going on. Okay, Kitty, answer this multiple choice for me. Okay, do we have answers, guys? Anybody with an answer for me? Okay, I'm seeing answers. Okay, let's mark. It says the stone thrown vertically downward from the building takes t seconds to strike the ground. Consider the acceleration time graph. Effect of friction is ignored. What does the shaded area 0 to t represent? Okay, now area is length times breadth, right? So let's multiply the area. What are we going to have? Area is what? A times t. Or which, if you see it, that's going to be what? A delta t. Where do I see that formula? VF equals to what? VI plus. Oh, lovely. Move this here. Minus VI equals to A. What is VF minus VI? Change. Correct answer? No. Oh, yeah. I'm saying constant and change. Okay, so the correct answer is what? V. I hope it makes sense. All right, it's the area. So we just multiply that and we get an answer. Everybody on the same page with me? Tricky little things here and there, eh?
So the best way to answer is just put it into a formula.
Yes. If they say gradients, then I would have said A divided by what? Delta T. Then look for the formula that has both and manipulate to see what I'm going to get. Okay. Oh, let's look at this one. Please answer. Simple things here. Come. Get me an answer for this one. Simple stuff. Hi, Sarah. You always arrive when after I do your question.
I really tried. My mom picked me up a bit late from school and I had to go home and eat quickly because I was really hungry after that whole hour.
Which one was your question? It was the generator one.
What was my question?
Not yet.
Oh.
I think I did the first one. The one with the generator was moved. It was doubled. I think you were the one that sent that one to me, if I'm right. But I don't worry, it's a simple thing. Okay, are we done? The diagram below shows a simplified electric motor. What are we using, right or left? Left. You are using right, but you are dancing. You are dancing now because you are giving me body. You're shaking you're using body moves. Generators is right, motors is left. How do I notice it's a motor? Look at this. That tells me it's a motor. So I'm using left hand rule. Okay, what do we know? Now check this. Look at this. So current is going this way. That's what I need. Left hand, I'm pointing to the south. Current is going this way. So I wish I could draw my thumb for those of you at home to see. But my thumb will be. I don't even remember what's it. My thumb is pointing down, which forces this thing to go anti-clockwise. So what's the rotate what? And it cannot be slip rings. Slip rings is for what? AC. Okay. So these two are wrong. We are dealing with what? A commutator. So the correct answer is what? D. I hope it makes sense. Okay, guys, what I'm going to do is I'm just going to record my thumb and send it to you so that you can see these things very well. They're not difficult. Okay, so far, let me see. You sent me this.
Yeah, I have that one. Towards the factor.
4. A factor of 4. So we use this formula because we want energy, which is what? V squared over R delta T. But if we double this, the voltage will also what? Double. So we replace that with 2V. So 2V squared then gives me 4V squared delta T over R. And that is my energy there. Yes. So it becomes, yes. The square, you see that square thing is always the problem. The squared is always the problem. Okay. And here we used area. They said area of this, so we multiplied area times, it's a rectangle.
Yeah.
Area times time, and we took that into that equation there to see that it's change in velocity. So option D. I know multiple choice is the one that normally slaps people left, right, and center. Oh, I love this one.
Oh, this is the junior and how many battles?
I love this one. Can I give you a few minutes to try? Did you do this one?
No, my school teacher did it. She said that.
Please try it.
She really took her very well.
That was that method.
She's like terrible.
I love it. Let's try it. So guys, do you have answers? Anybody with answers? And the question just requires you to do a bit of maths. You can't just, you need to do the maths. Here another D. Let's see. Okay, let me run through. Now, a pendulum bulb is raised to position A at the height h above the lowest point of its swing. C is released from point A. No, lowest swing C. Why am I reading like this? Lowest swing C. It is released from point A and swings through what? Point B with a speed VB and C with a speed what? VC. Okay, so here we have V and here is what? But by the way, V here, VA is what? 0. Okay. What is the relationship between VB and speed VC? Now, you must understand that mechanical energy is the same across. Mechanical energy at A is the same as mechanical energy at B and at C. And also remember, what is your mechanical energy? It is the kinetic plus potential, which is what? Half mv squared plus what? Mgh. Now, look at point A. Are you aware that my EMAC will only be what? Potential, which is mg. Why is that so? Because the velocity is 0. So that kinetic energy part goes away. What do I have at B? I'm going to have both of them, right? So what will it be? Half mvb squared plus mg. Now, what is the height from the ground? Okay, it's half what? 8. Beautiful. So can I put that there as h? Everything over what? 2. What about at C? It's only going to be what? Kinetic, which is what? Half mvc, because all the potential energy has now been converted to what? Kinetic. As the height reduces, potential energy decreases. And remember, when the object is moving down, velocity will increase. Therefore, kinetic energy what? Increases. Now we need to map all of this together. So the examiner wants a relationship between what? B and C. So let's put B and C together. What are we going to have? Half mvb squared plus what? mgh over 2, which is what? Half mvc squared. Do we agree? Here's the trick. Okay, I need to remove every other thing. The G and the H must disappear. M's are definitely going to cancel. So from here, I can actually cancel because it's half M, half M, half M. But before I cancel, I want you to see the little secret here. This one here is perfectly the same as this. Yes, they are both mechanical energy, remember?
Oh, yeah.
The mechanical energy is equal to that. The same mechanical energy is equal to that. So I want to get mgh. So instead of writing mgh, I'm going to put this there. So if I put that there, let's see what I'm going to have. 1 over 2 mvb what? Squared plus, let's say 1 over 2. Instead of writing mgh, mgh is this. The whole thing. Times 1 over 2 mvc what? Squared. You see, my 2 at the denominator is the first 1 over 2, right? Okay. And that is equal to what? 1 over 2 mvc what? Squared. Let's make it easy. All the 1 over 2 m's can now go. If I factor out 1 over 2 m, what do I have? VB squared equals to what? Half V, no. I want to write it out first. Plus half what? VC squared equals to what? VC squared. Can I move that VC squared over? What would I have? VB squared. That is 1 minus half, which gives me what? Half VC squared. Can we find the square root? So what would VB be? VB will be the square root of what? 1 over 2 VC squared, which can be written as, according to their answer, 0.5. But I think I know the square root of, okay, there are two answers here. My options are actually A or B. The one you said is not the answer. What is the square root of VC squared? VC. So can I put that outside? And I have root 1 over 2, which is what? Root 1 over what? Root 2 VC. But what is the square root of 1? So this can be written as 1 over what? Root 2 VC. Which is the same as, look at from here. What is half? 0.5, right? So those two options are actually the same. And that's my answer. Okay, I don't know if it makes sense. It is about playing around with your formulas. It's about playing around with the formulas, understanding the concepts, and algebra. You thought you were done with algebra. No, always there. So yeah, multiple choice, they're always quite tricky and challenging, especially if it has to do with calculations. Okay. Who gave me this? Okay, let's do with your electricity now. Since you said electricity always challenges you. Look, if you want to understand electricity, one thing you must learn. It's yours. Oh, this is your sailor. Okay. You must, but it will help. You must understand this acronym.
Yeah.
Huh? Okay, let's look at it. L1 and L2 are two light bulbs and have the following ratings. Okay, so I have L1 and I have L2, right? The two bulbs are connected. I wish I could just make this a bit bigger. Let me see if I can. And somebody's saying, what is this Chinese that this guy is writing here? Series are potential what? Dividers, parallel are current dividers. Once I can play with that, I'm good. Now, the two bulbs are connected as shown in the circuit diagram below. The battery has an internal resistance of 0.6 and the conducting wires and emitters, So we have this. You know, the first thing I love to do, before I even look at the question, is to trace the movement of current. Current is going to move like this, right? But when it gets here, it's going to split. And when it splits, I know it's what? Parallel. Once I see it splitting, then it will come here and it will what? Combine again and move. That means this one is what? Total what? Current. It means total current will go through here. It also means total current will go through here. It is only at that point that it splits. And what do I know? Parallel are current what? Dividers. And also don't forget the relationship between current and resistance. Inversely what? Proportional. So I have this already. Just an outlay. Now let's go and look at what the examiner wants us to do. Number one. Define the term what? Power. Do you remember what power is? Something. What's the formula for power? Guys, always first think about formulas. Power is W over what? Once I have a delta T as a denominator, bring in the word what?
Oh,
the rate at which work is done. Make sense? Or you can say the work done per unit time. So first think of the formula and try to manipulate. But if I see delta T as a denominator, I just use the word what? Rate. Okay, if the two light bulbs as rated below, as rated, operate as rated, calculate the reading on A2, reading on A1. Let's look at those two. Reading on A2. What do I know about A2? So I want the reading on A2 and the reading on what? A1. Is it A2 and A1? Okay, let's see. But there's something they told us about the light bulbs. What's this light bulb? They gave me the power, which makes it easy. 48 watt and 32 volt, 36 watt. And that gives me my answer already. I have power and I have voltage. For L2, let's calculate A2. It's about what you're given. Power equals to what? I multiplied by what? V. What is my power? 48. Do I know the current? Nope. Do I know the voltage? What's my voltage? 32. So what is I? Amps. We are done. 1, 2, 3.
So the amount of current that passes through, like say L1, is the same amount of pass through R1.
Yes. The current that passes through here, let's call this I1, will be what? I1. Why? Series are potential what? Divider, but current is the same.
So on top by L2, if A2 was another resistor, you give a different path.
Same current.
Okay.
So if this was another resistor, here, a light bulb, the same current passing is what comes.
Okay.
So current comes this way, gets here, and divides. And it maintains. Maintains, comes here, combines. Once you understand that, you can see what's going on. So the current here is the current here. The current here, because series are potential dividers, current remains the same. Now the examiner wants us to get A1, which is what? Total, which is this plus that. I'm sure we can get this now. Let's get that. So for A1, what do we start with? We start with the current in L1 first, right? So T again equals to what? I multiplied by V. What is P? 36 equals to what? I multiplied by 20. So what is I in L1? 1,8. Oh, lovely. So what is A1 going to be? 1,8 plus 1,5, which is what? 3,3 amps.
So even the voltage in the branch will remain the same.
Now the voltage here,
So R1 voltage plus L1 voltage will be equal to L2 voltage.
sorry,
R1 voltage plus L1 voltage will be equal to L2 voltage. So if you want, then you say 32 minus 2.
so already I know this is 2 volts. Why? Parallel are current what? Divider. The potential difference here is exactly the same as the potential difference here, but the potential difference is now divided. So if this is 32 here, 32 volts, it is also what? 32 volts. But that's why this is now 20, or this one is going to be what? 12. So the acronym is just what guides you all the time. Series are potential what? Divider. These two are connected in series. I don't know if those of us at home are okay so far. We need to run. I think I have 35 slides of questions. And some just came in now that I've not even added. I promise you, 35. Look. So we got to move. That I'm not even giving you. Normally I would say 10 minutes, 5 minutes, but I want to make sure I cover everything. So please be a sponge, soak in as much as you can, because I'm going to be moving. All right, we're done with that. Resistance of R1. Let's come back. I think we've discussed it. You know, we are done already. And guys, the idea, good. The idea is every time you calculate Write the answer
1.8.
on the circuit. Wait, what is the current here? 1 comma.
8.
So this is also what? 1,8 volts. 20. No, this is amps, right? Sorry. 20 volts. What would this be? 12 volts. Now I have my V equals to IR already. I'm done. 4 marks in the bag. Make sense? All right. Please you need to stop me because I'm going to be moving like a madman now, you know. I mean,
The EMF was fine. So then the last question was
this one. EMF. Okay, but let's see. What do we know? V equals to what? IR. What's my V? 12. But this is what I wanted to show. I wanted to show how you got the 12. 32 minus 20. Yes, talk to me quickly. I'm not looking at my screen, so you need to talk to me. What is my V? 12. What's my current? Times what? R. What is R? Remember, I just showed you where the 12 volts is coming from. 32 minus 20. 32. And I explained that because these things are parallel. The total voltage here is what? 32 volts. The total voltage here is what? 32 volts. But I know this as 20. This must be 12 to make up the 32. Series are potential what? Dividers. Okay. So once you keep that acronym, subtract, add, play around with your stuff, you're going to be okay. EMF of the battery, what do we know?
So you can get the external voltage.
Do you know that you guys are even, wait, you guys are even going very long. You guys are saying what? E equals to what? I, if I find the total R, that's too long. The total external voltage is 32.
No, sir, there's a 4 ohm resistor.
Oh, there's a 4 ohms there. Okay, but the voltage here is what? 32, right? Because with that way, you know what? I'll have to first get the resistance here. It's too long. So the voltage here is what? 32. But remember, what is my total current again? 3,3. That 3,3 passes through here. So can we get the total voltage there? It's always VIR per resistor. VIR. So let's get the V. And we know my V internal already. Do you know the total current here is 3,3? And this would give me what? V internal.
The V internal is the lost volt.
Lost volts. And I know my V external. Okay, let's do it together. I want to carry everybody along on this one quickly. So it's about careful what? Analysis. Now, what is the voltage in R2? Voltage in R2. We know it's equal to what? I times what? R. What is my current? 3,3 times 4. What do I have? 13. Oh, all right, beautiful. So the total external voltage would be what? 13,2 plus 32. How are we adding? They are connected in series. Series are potential what? Dividers. What's your answer? 45,2 volts. Okay. What is our V internal? It is current multiplied by small what? R. What's my current? 3,3. What is my small r? And what would that give us? 19,8.
Yes. So 1,9.
1,98. So what is my EMF? V external plus V internal. 45,2 plus 1,98. What's your answer? You sure?
Yeah.
47, it's easier than finding, because you have to find resistors, then calculate total resistance again. And did it make sense, everybody? It's about analysis. Whatever you get, also right there. All right, everybody good? Let's see my YouTubers. I hope everyone is good. Okay, let's look at the last one. Bulb B1, no. Bulb L1 burns out after a while. Okay. Assume the resistance of bulb L2 remains the same. Will bulb L2 continue to glow? Interesting. Choose yes or no with the calculation. Okay. Interesting. I see why you sent this one. This was the juice in the question. Okay, let's see. They said, which one burns out again? L1 burns out, right? Okay. Let me clean this because all of this will change. Now, if L1 burns out, right? Okay, lovely.
When they say it burns out, do they mean like is it kept in the circuit?
Yes. If it burns out now, if this one burns out, you know what happens? It's like an open switch. So this guy will not work.
Oh, so R1 wouldn't work.
Everything in that line.
It's connected in series to R1.
Yes. So the only thing that is working is this. Becomes a series connection. But no matter what happens, the EMF of the battery will not change. What's my EMF again? 47,18. Okay, let's see something. EMF is 47, what? 18 volts. We want to calculate if this one will still work. And the best way to calculate it would be to calculate the current. No, we know the current that L2 will allow to pass through. 1,5.
Yeah.
Good. Because remember, the light bulb is still working. No, is it L1? L2. The light bulb is still working with that power rating. So that's what we want to check. If the current that this thing is now going to produce will be more than 1,5, it will also burn out. It will explode. It only has the capacity.
You want to know if it will be able to withstand that.
Yes. So what we need to do is to find current and compare with 1,5. If the current is too much, it will blow up that light bulb.
So the maximum current will allow is
1.5. Because it's rated to work with 1.5. So let's go calculate the new current. What do we know? So our old current no longer works, right? But the light bulb can still accommodate what? 1.5. Okay, let's see something. What will the new current be? How would we get? Oh, wait. You know what we can do? Let's calculate the resistance. It's going to be very easy that way. What is the resistance of L2? Because we can get the resistance of L2, right? By saying what? P equals to V squared over R. What's our power? 48. 32 what? Squared. Please give me an answer quickly. What is R of L2? Come, calculate.
21,33.
21,33. Now, what is the total resistance? 21,33 plus 4. Remember, let's write the formula as well. What's our formula? R total is what? R1 plus R2. Oh, this gives us 25, okay, let's calculate the current that we are expecting from the battery now. I into what? R plus R. What's our E? 47,18. What is our R? 25,33 plus 0,6. Give 1, it's going to blow. You're just going to hear kaboom. Makes sense. I don't know if it,
The EMF and internal resistance remain the same.
except we change the battery. Let me know if it makes sense, everybody. But we've not, you know, if you end here, you're going to lose 1 mark. You have to put the what? No. Will it continue to glow? No.
The 1.8.
Yeah. You can say,
Basically, we got maybe the whole fuse gas.
kaboom. So that's what we wanted to test there. To say, will the light bulb be able to withstand excess current? If it was equal to 1,5, we're fine. If it's lower than 1,5, we're okay. But any 1,51, no. Maximum capacity. So if you go back now with this knowledge, you can do any circuit question. Your SAPD, PAID. Okay, beautiful. All right. Okay, let's see. Who sent me this?
Yeah.
Huh?
Sure.
Oh, it's Michelle. Michelle, are you here?
Yes.
Michelle.
I did this with you, I'm not sure. I think I said this to you.
John.
I think it was like swimming with correctly. I think it's the 5.4. Yeah, it was there.
Okay, let's look at this question together.
Yeah, so I said the 5.4. The power delivered and the graph from point B to point C.
So this is yours as well.
Yeah.
Okay, let's run through from the beginning so we can have an understanding of what's going on. A roller coaster car of mass 200 kilograms with its engine switched off. You need to read that statement very well. Engine switched what? Off. It means there's no power, no force applied. All right, travels along track ABC, which has a rough surface friction, as shown in the diagram below. At point A, which is 10 meters above the ground, the speed of the car is 4. Okay, we are giving that information as well. Ignore that. Guys, please, your definitions are very important. Define the term non-conservative what? Force. It is the force for which the work done depends on the path taken. Please, there's nothing I can do other than to say it right now. You need to go and learn to write. Calculate the change in the kinetic energy of the car after it has traveled from A to B. Change in kinetic energy would simply be what? Final kinetic energy minus the initial kinetic energy. And I think that's very straightforward. Okay, so 5.2. Change.
They gave you the velocities.
They gave us the velocities. Would be what? Half m vf squared minus vi squared, which is half. What's the mass? 4. Oh, sorry, 200. My height is looking at that speed. 200. What is our final velocity? 2 squared. Please give me an answer.
Negative 1,200.
Negative?
1,200.
But don't leave your answer with a negative. This is simply energy what? Loss. Don't leave your answer with a negative. Why? It is a scalar quantity. Use the principles of energy principles to calculate the height what? H. What would I use? I would use, can I use work done by non-conservative at this point? Because they said at point B, let me see, which is a height h above the ground, the speed of the car is 2 meters. During this motion from A to B, all right, good. We're given what? The work done to overcome what? Friction. Check this. So I prefer this one. Work done by non-conservative equals to what? change in kinetic. I love this one. I love this one. This one is very straightforward. What are my non-conservative forces, by the way? Felt forces. All right. So don't forget friction, applied tension. Now, so in this case, I only have what? Friction. So which is what? Friction, delta x, cos theta, which I don't need, by the way, or which I have, half m. Oh, don't I know this already, right? Lovely. What is missing? mg h final minus h initial. Now, what is the work done by kinetic energy? Good. If you don't put the negative, that's where you've got to throw in, because work done to overcome energy is always a negative work done. They will not tell you it's negative. Yes, that's the cos 180. So this is negative 3,4. Please take note. They will not tell you that it's negative. Why is it negative? Friction removes energy from a system. And when the energy slows down, it means we have negative. What is my change in kinetic energy? Negative 1200 plus 400, 9,8. Where did I see 4 from? I don't know. The 4 is just in my head. Now, what's the final height? H. What's the initial height? 10. Please do the maths. Please quickly do the maths for me. For this lesson, I just want you to listen and follow through. Please. Good point. Can we confirm? Everybody, please do the maths. Move things over. If you need to write down steps, please do. Write down steps. Move that over. And then, Okay, I'm getting answers already. 8,88. Kian is giving me 8,88 as well. So guys, it is important to know that your energy for friction is negative, especially a force that opposes the direction of motion.
So even if friction is actually the direction of motion, the work is still
Negative. Because the speed is decreasing. You see, at this point, there are a lot of things responsible. Number one, there's friction. So this object slides down, but on its way up. Number two, the height is not yet up to here. So it has not gained enough momentum. Okay. On reaching point B, the car's engine is switched on. Applied force. So you got to read those words now. Remember, I underlined engine switched off.
So now it's the force of the engine.
Now there's applied force now. Because the engine is now working, driving the whole car. In order to move up. Otherwise, it's not going to move up to more than a particular point. Okay, to point C, which is 22 meters above the ground. While moving from point B to C, the car travels for 15 seconds at a constant speed of what? 2 meters per second. While the average frictional force of 50 Newton acts on it. Calculate the power delivered by the engine to move the car. We are looking for what? Force applied. Or work done by force applied. We can use that. There are quite a few other ways that we can use. Let's see first, guys, what do we have? Let's see what we have first. Okay, definitely. Okay, hold on. Let's do something for clarity. What do we know? Force of gravity. Now, the applied force is present because the engine is at work. But friction will oppose. So what do we have? Friction, Fg, force applied, and of course, normal force. I would like to use work done by non-conservative. So what would that be? The work done by non-conservative is change in kinetic plus change in what? Potential. Now, what is the work done by non-conservative? It is the first work done by friction plus work done by force applied. Is that fine? And that is half m v. Don't worry, we'll deal with it here, just here. There won't be a change, so it would lead me to what? A 0. Plus change in kinetic energy, mg hf minus what? Hi. Okay, let's now start. The work done by friction, what's the formula? Friction, delta x, cos theta. Okay. We do not know delta x.
If you speed is equal to distance over time, you have delta x.
Okay, yeah, we can use that. Or let me see something. Okay, friction theta is what? 0.
Minus the h.
No, we cannot. This is always our delta x. This is delta x.
Oh,
It's different
yeah,
from the
you
height.
need the height of these, you need the-
But no, we can actually use that 15 seconds because it's moving at a constant what? Speed. So we know that what? Speed is what? Delta x over what? Delta t. Yeah, you can.
You get a mark for that.
Yes. I know you have been traumatized by that formula.
Yeah, just like distance divided by.
No, it's the same. It's yes, in a way. In a way. Why? Why is it not written like that? Acceleration is equal to 0 because of constant what? Speed. Okay. So let's show that our velocity is what? Delta x over what? Remember grade 10, this is where we started from. So it does work. What's my speed? Constant speed of what? 2 over what? Time is 15. So my delta x is what? 50. No, 30. Okay, beautiful. Now, what is my formula? It is F friction delta x cos what? Theta plus. That's what we are looking for. Calculate the power delivered by the engine. So we don't know the force. Okay, so can I say force applied? Delta x, which we know. Cos what? Okay, I'm going to put all my substitutions later. Power, yes. No, that is energy. There's a difference between power is the rate at which energy. Okay. Even if I can leave this one like this, I can still leave it. In fact, let's leave it because that will then be what? Work done by the applied force. Let's leave it. We don't need to get the force.
Then you have to calculate it.
Okay, no, that won't be my answer.
Then you have to calculate for force applied.
No.
So you just need, so you basically just looking for.
Okay, guys, you are bombarding me. But I want to show you where I'm going. All right. Vf what? Squared minus plus mg hf minus what? Hi. Now, do I know my friction? 50. Do I know my delta x? 30. For friction, it's always what? 180. Okay, I'm going to keep this. Half. What is the mass? 200. Now, what's the final velocity? It's a constant speed. So my final velocity is what? 2 squared. My initial velocity is what? 2 squared that I'm dealing with your 0 now, plus 200. What is G? Now, what's the final height? 22 minus 8 comma. Do you understand the 8 comma 88? It's between B and C. We got this height as 8 comma 88. So the height at B, that's the initial, and this becomes the final. Please do the maths for me. Get me the work done by the applied force, which is the work done by the engine. No, power is different. Power is W over delta T. Then I bring in now my delta T divided by what? 15. Power is the rate at which work is done. This is giving the energy I want the power. Yes, that lady?
Yes, sir. So I'm not understanding.
Hi, Nana.
I'm not understanding the final velocity being the initial velocity being 2.
Let's read two questions together. Did you read? Because that's here. It's here. On reaching point B, the car's engine is switched on in order to move up the incline at point C. What's the velocity at B? 2. Right?
Yes, sir.
Okay. While moving from point B to C, the car travels for what? 15 seconds
15
at
seconds.
a constant speed of what?
2 meters per second or
That means it maintains 2 meters per second.
throughout. Okay. Thank you, sir.
That's where the 2 comes from.
So
Thank you, sir.
Yes, Brian? Okay, you're welcome, lady.
there's the 15 newtons in the frictional force. Does it also include gravity parallel?
If I use this formula, I don't need gravity parallel.
Okay.
So that's why I like to use this formula. Once I use this one, I'm done with all those FG parallel sine theta. It takes that away completely. If you use this one, but if I use W net, I'll have to bring in gravity.
Okay, so gravity is excluded from this.
Non-conservative forces, friction,
Oh, yes,
applied
it's friction,
tension.
applied tension.
So it makes it easy.
Yeah.
For all those
So
FG
easy when
sine
you
theta,
apply the substitution, yeah.
and then you start putting theta and theta. Give me an answer here quickly. 27. Do we agree? 27215, 2 joules. Do we agree? Two 2 divided by what? 15.
Oh, I'm going to 4215.2.
Okay, guys, can we confirm? Oh, Michelle also gave me 27215.
So you take gravity, you add that.
Just move, yeah. So it is 200 times 9,8. Because 180 is negative.
So you would add it or not.
Yeah. So 200 multiplied by what? 9,8. 22 minus what? 8,8. Is that fine? That gives me that. Am I right?
Yeah,
Yes.
yes.
Okay.
Plus,
Plus, why are you guys getting the 0.2 from now?
So 8,88. Yeah.
Oh, okay. I'm wondering now what's going on. 8,88. All right. Okay, makes sense now. Now on the left, I have negative 1500. So plus 1500 would give me 272. Now divided by what? 15, because we're looking for power. Work over time. 18.
171.
What do you mean? What did I do? 1814, what? 1814, 35 watts. Power.
Can you use in the last step of power everything as we go to force times velocity?
That is if I get my force. So that is if I expanded this one,
So we're solving then for the force.
you have to get the force first, then multiply the force,
Multiply that by the 2.
yeah, with the speed of 2. But that's extra work. Because I can show you, look at this. If I tell, look at this. Let me show you how that formula comes to be. What is my work applied? The work applied is basically force applied, delta x, cos what? Theta, which is 0, which is 1.
Yeah.
Right? Now, if I divide by time,
Oh,
that is your force.
then
So this is going to be my power now. Right? Force. So this is my power. Okay, let me do this. Power is W over what? Delta T. So you just be going in circles. All right. Question done. What is this?
I sent it, but I got it.
Okay, let's look at it. Universal. I know you guys are looking at R squared, and then you're like, oh no.
It's a lot of math, and then you just have to substitute things.
Okay, let's see quickly. For 4 marks, let's see. A learner wants to calculate the distance between the Earth and the Moon. Why? That's the question I want to. Okay, but why? Dude, there's AI. Just ask. Okay. All right. Where the net gravitational force is 0. To achieve this, the learner placed a third mass M at the point. How did you get there? How? Because I'm just going to say, but how did this learner get here? Okay. In the diagram, the distance between the centers of the Earth and the Moon is R. Okay, lovely. State Newton's law of universal what? Gravitation. Please let's go learn the laws again. Every object attracts what? Each other with the force that is what? Directly proportional to the product of the masses and inversely proportional to the square of the distance between their centers. If you say between them, it's wrong. Between their centers. Okay, use the law of gravitational to show that R and X are related by the following equation. Okay, beautiful. Do we have a formula, by the way? Okay, but check. The examiner says something. They said, Elena wants to calculate the distance between where the, all right, to achieve this, Elena placed a third mass M at point what? P. So we need to focus on P. Right? Okay. If I look at point P, what's happening? The Earth is pulling it. If I look at the Moon is also pulling. So can I say this is what? F of the Earth and on the P and F of the Moon on the P. We're back to electrostatics, right? Plus and minus. So if we choose that one was positive, the other one becomes what? Negative. Okay, so can we then say F net? Do you see where the net gravitational force is 0? So if I choose this one as positive, this one will become what? Okay, beautiful. So they are equal to each other. F net is what? Force of Moon on P. I'm writing the positive first, right? Minus force of Earth on P. And this is what? 0. F of MP minus F of. So if we move that over to the other side, what do you notice? F of EP is the same as what? F of MP. Now, do we know F? G, mass of the Earth, mass of P, over what? R squared, according to the original formula, right? Will be equal to what? G, mass of what? The Moon, mass of what? P, over what? R squared. My G is the same, by the way. My MPs are the same, by the way. So mass of the Earth over what? Okay, what's the mass of the Earth?
9.97.
Oh, I was looking at that. What? Okay, we are just okay. Mass of the Earth 5, what? 97. You can see the way I was looking at that. Guys, what's wrong with you? You swallowed over what? R squared. Now, the distance here is the question. What is our R? We are looking at the Earth and the P, x squared. Is that fine? Equals to mass of the moon, 7, what? 35 times 10 to the power what? 22. Now, what is the distance here? R minus x. All what? Squared. Let's do the maths now. Come. Let's do the maths. Let me do this so I can get a fresh page because it looks like it's about to go down. Okay. What would you do? I would switch the numbers. Would it work for me? Yes.
Who do you use? I don't let anyone tell you.
Okay. I would say R minus x squared over x squared equals to 7,35 times 10 to the power 22 over 5,97. I think you can help me with an answer there. John?
Yeah.
I moved this one, I moved it here, and I brought this one here. I cross multiply and divided at the same time. So I can switch. 49? Huh? 49 over?
Now you're dealing with your F.
Now wait, let me check something. What are we getting? We have an x squared, right?
Yeah.
I didn't want that. So I was going to look for squares of both sides and give me r minus x, but they want they want x squared. Okay, so let's spoil. R squared minus 2rx plus x squared. Is that fine? Okay, so the 49, we're going to have 49x squared there, right? But
Yes, then you just bring it over.
But give me this as a decimal, because I see they're getting a decimal there.
0,01.
0,012, but then you have to subtract
Yeah.
the 1 to give you the 0.
Okay, so we have r squared minus 2rx plus x squared. Give me that again in decimal. 0,012 cross multiply x squared. Now let's move this one here. What do we have? R squared minus 2rx. This is 1 minus, because there's a 1 here. What will that give me? 9877. Is that what they want?
Yeah.
Not bad. It's about, I wanted to learn that what made it easy was the fact that, check this, this was what reduced the messiness.
You just look at the question.
Because you'll be looking at 6,67 times 10 to the power, then you multiply that, and you want to divide. So please, let's learn to cancel things out. Did it make sense, everybody? We got to run. Everybody okay? Lovely. Lovely. All right. Let's look at this one. You hear it? I think, who said, Michelle, this is yours. I remember this. Yeah, she wants, that child wants to kill me. But it's okay. I refuse to die.
Wait, sir, I only asked for the last question. Eh?
But, Church, you only, I know, you only asked for the last question. How can I jump to the last question?
Yeah,
I don't know what's going on from the top. But it's okay. It's fun. It's fun for me, and it's revision for everybody as well. So let's run through. Don't worry. Don't feel bad. I'm doing my job. Okay. Up to you too. In the diagram below, a small object of mass 2 kg is sliding a constant what? They even underlined it here for you. Okay, of 1,5 down a rough. Those are my keywords. A rough means there's what? Friction at 7 degrees to the horizontal. At the bottom of the plane, the object continues sliding down on a rough horizontal surface and eventually comes to what? Stop. The coefficient of kinetic friction between the object and the surface is the same for both the inclined surface and horizontal. Okay. Write down.
Eventually accelerate.
Sorry?
If it's time to stop, you can't just continue at constant velocity.
No, it will come to a stop because of friction. We said in the diagram, a small object at 1,5 down a rough. So it's only moving at 1,5.
We didn't accelerate it.
No, because they told us it's constant. Then from here, it starts slowing down because they said down a rough.
Friction was to stop.
No, there's friction not that the friction is part of it, but it's no longer inclined. You see, the reason why it's not stopping, here is force of gravity is pulling it down.
The speed with it is
Horizontally now, the speed starts decreasing until it gets to what? 0. Write down the magnitude of the net force acting on the object.
0.
That's 0. Simple. Why is it 0? For the first one, check. Acceleration equals to what? 0. But what is F net? F net equals to what? M A. So F net is 0. 1 is done. Draw a label. Please, everybody draw. I don't want to draw this. Everyone should be able to draw because I'm going to draw it now and spoil you. Please draw. Huh? No, you want to say a force diagram.
Yeah.
Force is you draw a box. Everybody, you draw a dot.
A box and all the forces deviate from the box.
Yes. But a free body diagram, you just draw.
And a dactyl diagram is the triangle.
Not really. You can draw a box. Guys, are we done? Yes? On the inclined.
So,
Yes?
do we have to write a key for the forces that we have in our free body
Do you have-
diagram?
Do you have to do what?
Have a key.
Why do you want to write a key? Just write the whole thing in full at once. There's no need for keys. That one you are wasting time. So, what are we doing? What forces do we have? Normal force. Oh, let me use white. So don't create keys. It's extra work. Normal force, force of gravity, and friction. Write it once in full. Force of gravity. You don't need a key. What do you have here? Normal. And what do we have here? Friction. We are done with our question. Done. Calculate the coefficient of kinetic friction between the object and the surfaces. What do we know? First, I always ask myself, what's the formula for friction? What is it? Fk equals to what? Mu Kn. Okay, but let's see something here. What do we have? Do we have friction?
But the friction would be equal to the parallel.
They told us F net is what? Equal to 0. All right. So I don't like this diagram this way. You should know. What do? I draw my components, right? What will my component look like? Normal. Is that fine for us? Friction. What next? FG parallel. And FG what? Perpendicular. FG parallel, frictional force, and instantly I'm going to write my formulas. What are my formulas here? Mg sine alpha. What's my formula here? Mg Please don't make a mistake. If once you switch this, forget the whole thing is you're done. Please don't make a mistake. All right. Because the object is moving at constant speed, we say F net equals to what? 0. Okay, so let's go back there. F net is what? 0. Let's take the direction of motion as positive. That's what? So what do you have? FG parallel plus negative what? Friction equals to what? Can I move that friction over there? What do I have? FG parallel equals to what? Friction. What is FG parallel? mg sine, I like to use alpha. What is my friction? Mu k n. The question is, what is n? Mg cos. You see, they are opposite each other. Does that make sense? Do we know the mass? 2 kg. And let's substitute. 2, 9,8. Sine what? 7, I think. Okay, remember what my n is. It is mg. I can also use 10, but it's fine. Then let me start doing things. I can use 10. Sine over cos there. But don't go and use it, please. Let's do normal stuff. Cos what? 7 degrees. Can I just divide? Answer is actually times 7. 0, comma, and there's no unit, right? Remember? Why is there no unit? It's a ratio. Ratios don't have units.
So when kinetic friction is upward slope, you use cos.
Huh?
When kinetic friction is upward slope.
What do you mean? Which cos are you talking about?
No, we're not talking. No.
Normal is opposite FG perpendicular. That's where the cos is coming from. Are we on the same page, everybody? Please let me know. Are we on the same page? 0, 1, 2. Can I move on? Now, we were told something that I read. They said the coefficient of friction is the same for both the inclined and the horizontal. Yeah. Calculate the distance the object travels on the horizontal surface before it comes to what? To stop. Look, very, very, let's look at it. So if I were to draw the horizontal surface, what is our speed here? 2 meters per second. But we are told it comes to stop at what? So 0 then. What is the coefficient of friction? 0, 1, 2, right? Now, if I were to draw a free body diagram here, what would you draw? I will draw my normal force, which is now vertical. I will draw my gravitational force, and I will draw what? Friction. Does that make sense to us? What am I looking for? Distance. Let's quickly think. Which formula has distance? I'll have to go back to equations of what? Motion.
Yes.
Now, I don't have time, but I have VF and VI. Can I say VF squared equals to what? VI squared plus 2A delta X. Do I know VF? Yes. Do I know VI? Yes. Do I know A? No. Don't bring in 9,8, please. But I know that F net equals to what? MA. How many forces are acting here? Only one. Friction. Does that make sense? But do I know my, so this is what? Friction equals to what? MA. The question is, do I know friction? No. But friction is what? Mu K N. Does that make sense to us? And this time around, my N is what? Mg, not Mg cos anymore. That's why you must get your free body diagrams correct. There, my N is Mg cos. In this case, my N is what? Mg. Can I replace it by saying mu K Mg equals to what? Ma. Two. The G and the A don't cancel, remember? So what is A? My mu K is what? 0, comma what? 1, 2 times what? But there's something I want to show you here. 0, comma?
1, 1.
1, comma? Please, guys, what do you think is happening to the acceleration? This object is actually decelerating. It's going to be negative. Must put that at the back of your mind. My speed is decreasing, so my acceleration is what? Negative. So what do I have? Let's fix it now. 0 squared. You have to substitute the negative. And I have what? Delta x. Please do the maths. Get me delta x, everybody. So please take note. Negative because of what? Deceleration. Negative? 69. 1,69 meters. That's the one. No, distance.
No, not this one. No.
Coefficient of friction. No, what are you talking about? Oh, they ask us to calculate. I skipped that one. But that one, you pick it along the way here. Because friction is what? Mu K N. 0,12. What is my normal here? Mg cos.
You saw already the previous question, you just rewrite it.
We didn't solve for this at all. Do you notice? We were just keeping it all
So
along.
the lesson we saw something that they again.
You actually shouldn't solve before they ask you to. No, don't put the arrow. Please rewrite it. But you shouldn't do it. Mg cos what? 7, I think. You should be losing the mark. Really? Okay, guys, I'm done here. I'm sure you can handle this. Your calculator can help you with that. Distance, is it fine with everybody? Let me know if there's any question on this page. Quickly. Ooh, I'm on slide what? Oh la la. Plus I've added slides. Yes, now lady.
So when we are substituting the new value of n, why aren't we including cos theta? Because it's mg cos theta. Why are we just writing it as mg?
I did explain my diagram. That's why your free body diagram. Look at your free body diagram here, Nana. N, that is Ng, not Mg cos. It's not on an incline anymore.
Oh, yes, okay.
Yeah,
Sir.
it's an incline. So please, let's master this formula. Mg cos, that is my N. But here, Mg. So the examiner is playing around with you, do you know how to do a free body diagram? Beautiful question, guys. Let the questions come in. This is yours. But I think we can run through very fast now. Okay, let's run through, guys. 3 resistors and an electrical device rated 16. I wish I can just close my brain and just borrow you a few tomorrow and return it, guys. Huh? You're not returning. That's after finals.
Yeah, after that.
All right, let's check. 3 resistors and an electrical device of 16 watts, okay, are connected to a battery, 36 volts, and an unknown internal resistance as shown, okay. Ammeter A2 is what? 2A when the switch is closed. You know what I would do, like I did earlier on? Just get my pencil. What do you think we should do? Trace the flow of what? Current. Okay, this thing doesn't want to respond. I want to make it bigger. But if I were to trace the flow of current, what would I have? Current is going from the positive, right? Check here. What happens? It splits. Yes. And split tells me it's parallel. Now, what's the current here? 2. It means it's what? It means it's what? Does that make sense? Now, whatever current passes through here will come here and what? Combine. And then this will be what? Total. And this one will also be what? total, and then I go back to my. Once you do that first, we're good. Define the term EMF. EMF is the maximum energy supplied by a battery. So please write for me. I'll borrow you my school uniform. Glazer. Okay. They said there's no impersonation. You and I will both go to jail. That one is not that. Ban from 3 years is fine. Jail, bro. Can't do that. Okay. All right. EMF, we're good. Calculate the resistance of the electrical device. Now look at your device. You have power, you have current. What do? No, I don't need V. P equals to what? I squared R. So what do we have? What's my power? 16. No, I don't know. No, I know I, right? 2 squared. Come on. So what is R? 4 ohms. We are done there. Number 2. Current passing through the battery. 5 beautiful marks. Already I told you how to. I told you the movement of current, right?
Yes, I total.
That's I total. Now let's look at something. Already, I already know this is 2. So let me use something everybody can see. That is 2. So we don't have a problem here. Our problem is here. Right? Now, how is this connected to this side? It's parallel. So if I can get the voltage here, wait, hold on. My acronym, what's my acronym saying? Series are potential what? Dividers. That means, can we get the voltage here?
Yes.
Which is 16 volts. Can we get the voltage here? 4. No, but don't I know my R? My R is what? 4. V equals to IR. That's to give me what? 8. Now, please check. I'm going to make it very simple now. The total voltage there is what? 24. Watch this. If I were to do my circuit, sometimes you need to redraw to make it easy for you. Look at, I have my 10 ohms, right? If I combine these two, I'm going to have something like that. So the total voltage here is what? 24 volts. How are these things connected? Parallel. Now I can calculate the current in the 10 ohms and then add them together. Does that make sense? Steps. V8 equals to what? I8 multiplied by what? R8. Do I know my current? Yes. 2 times 8, which is what? 16 volts. That's the first thing I calculated. Voltage in the device equals to I device multiplied by what? R device. What's my I? 2 times 4, which is what? 8 volts. Total voltage of V in the parallel. V in the parallel is therefore 16 plus 8, which is what? 24 volts. Therefore, the V in the 10 ohms is also what? 24 volts. So V10 is I10 R10. Do I know my voltage? 24. Do I know my current? Nope. Do I know my resistance? 10. What's the current there? 2,4 what? Amps. Total current, therefore, is 2,4 plus 2. 4,4 volts. Please let me know, guys, if, oh, sorry, what did I write? Voltage. Let me know if it makes sense, everybody. You see, it's fast now when I calculate because I've already done my calculation on the screen there. Pop, 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 pop. You connect the wires in the exam hall, blow everybody up, and you know. Guys, are we on the same page? Please talk to me. Let's run.
It's flex. If you add them together, then that will be your I total.
Yes. So it's all about first analyzing, then it makes it easy.
Yeah.
So I know my current here is what? 2,4 amps. Now when it comes down here, it combines. So what will be going here will be what? 4,4. And then what goes in here is 4,4 volts. No. Amps. Take time to analyze before you even read. Okay. What are we looking for now? Another 6 marks. Beautiful. Well, okay, let's see.
The voltage going through the battery, then take it through the 2 ohm. Yeah. And then it's get
The voltage going through there?
battery.
Plus that 2 ohms the voltage to the base. We have down to the back.
All right, what you guys talking about? I don't see you guys working for ESCOM. What you're saying. This 20, is that this 24? It's not the 24 going through. No, he was saying I should move the 24 here. No, these are connected in series. Series are potential what? Dividers. That's why this is not giving me 24. You know that I can get the voltage there. This is actually too much for 6 marks though.
So when after we add the voltage level to give the external,
So I can use that and get my V external.
then we have total times and solve for internal resistance.
Do we have internal resistance, by the way?
That was solving.
Oh, we're looking for it. Ah, guys, I have EMF. Why 6 marks? This is not 6 marks at all, but maybe 6 marks for thinking. The V in the 2 ohms. Come, let's work together. It's going to be what? I in the 2 and R in what? The 2. What is the I in the 2? 4,4 times what? 2. What would that give us? 8,8 what? Volt. Now, what is the total external voltage? 8,8 plus 24. If you want to see it again, how I did that, remember we had those parallel, right? Which we can combine, and then we have that. Now, do we know? Oh, so we know that what EMF is what? V external plus what? V internal, which can be written as V external plus I multiplied by what? Small r. What's my EMF? 36. What's my V external? Oh, I didn't put this one. 32,8. What is my total current? 4,4. Please get me an answer. Let me see. While you're getting the answer, I want to see where the 6 marks come from. 1, 2, 3, 4, 5. What's the answer?
0.7.
Okay. So that's where the 6 marks came from. That is where the 6 marks came from. I hope you're okay. Switch S is now opened. How will the reading on the ammeter? All we need to do is to check what happens to the value of the resistance, total resistance in the circuit. Which ammeter? Ammeter what? A1, which is measuring total. Guys, if I open this, I am cutting this entire thing out. If I cut out a parallel connection, my total resistance will increase. If you are not sure, just calculate this. Those 2 marks are important. But total resistance will what? This is the only one. It's just these 2 working now. So it will be 12 volts. 12 what? Ohms. So what happens? Let's write our answer. Total what? Resistance will increase. Please write this as well over I. Therefore, total what? Current will decrease. Guys, if you are not sure, please calculate the resistance first. Then calculate the new one when we open the switch. And when we open the switch, the 8 ohms is not working, neither is the device in operation. I wanted to say, why 2 questions? Okay. A person of mass 60 kg climbs on top of a mountain which is 6,000 meters above the ground level. State Newton's law of universal. Can I skip that?
Yes.
That's on you. Calculate the difference in weight of the climber at where? The top. Do you know what weight is?
Yes, thank you.
Right. Do you know this formula? Do you know that this force there is weight? This.
That's like a cruise. Last year we experienced right now, very fast.
That's weight.
Oh, yeah.
There's a proof where they now where we combine this and you get one single formula for G.
Last year we wanted
Because check, that is mg is equal to G capital M small m over what? So that the examiner says the weight, they only change that. They want you to use this formula. So now let's calculate the weight. Let's call it top and bottom, right? Top and what? Okay. What is going to be the weight at the top? Weight at the top would what? G M small m over what? R squared. Oh, now I don't have what is my G? Do you have a formula page yet? Okay, let's open one. 6,63.
So why are you not using the force?
Which one?
The first,
It's the same.
so it's the same.
F is the same as the weight. So I want to calculate the weight on top, the weight at the bottom, and subtract. Because I said difference in
You
weight.
just canceled out to get the new formula.
No, this one I was just explaining stuff here. This one I was just explaining something here. Yes, Kian?
So how are you getting 6,63 times 10 to the negative 34 when the constant is 6,67 times 10 to the negative 11?
Okay, I can't hear you very well.
I think 6.11 times 10 to the negative 37.
Let's get a formula page. I'm tired, guys. I guess move. Where's my formula page, man?
So do you use the formula for gravitation and acceleration?
No, I'm not. I'm using my formula for force. I'm using the F formula. What I told you is that F is weight. So when I write F equals to GM1, GM2 over what? R squared. That F is also known as the weight. Okay, let's just pick anyone here. So they only want to trick you that if you don't know that F is the weight.
So you can substitute it normally.
Yeah, it's just the same formula. The same. I was just using that to prove this formula for you.
Oh, okay. Prove the
You see what I did earlier?
Oh, so you did a gravitation acceleration.
Oh, now it's gone. Gravity is pulling it, eh? I was just proving that G equals to G acceleration. That's all. But this is the formula I'm using. GM1 M2 over what? R squared. Okay, let's get the value of G. 6,67 times 10 to the power negative what? 11. Come, let's read quickly. 6,67 times 10 to the power what? Negative 11. What is the mass of the Earth? We need that mass. We need the mass of the Earth. 5,98 times 10 to the power 24. 5,98 times 10 to the power. Now the mass of the, do we know the mass? 60. Where? Oh, 60. over. Now, what is the distance? This guy is on the surface of the earth.
So
I need the radius. So 6,000 plus what is the radius of the earth? I'm glad you guys are seeing that now. 6,38 times 10 to the power what? 6.
This is above.
Don't forget, it is all what? Squared. Guys, can I just do both at the same time? G M M over what? R squared. Since they said the difference, minus 6 comma what? 6. Okay, now we're going to check now. Wait. What is the mass of the earth? It still continues, right? 5,98 times 10 to the power what? 24. What's the mass of the person? 60. Now, the difference between the two is just this now. Where is the guy standing now? On the earth. That 6,000 is no longer there. But this guy is still standing far from the radius of the earth. So what do we have? 6,38 times 10 to the power what? 6. Put that in a calculator and we are done. Did that make sense, everybody?
actually, Dr. Sir is not working.
Guys, is the explanation making sense? I want to see if we can just move. Just by understanding what's going on.
It's not the difference between the same.
Huh?
How do we know that it's in the radius?
Whenever you're dealing with gravitational, it's the center of the object. Because this is what. No, it is. That is this. And this is the guy.
Oh.
The guy is first here. Let's draw a blue guy. The guy is here on the surface, and then the guy is here. 6,000. Everything is in reference to the center. So when the guy was 6,000 above, check, it is the radius plus the distance above.
Yeah, it's just the radius. Oh,
1 comma?
10.
Is that the final answer? 1,104 newtons. Weight is a force.
So
Yes?
yeah, I got it as a negative answer.
Sorry?
I got it as a negative answer.
Then that means we just swap it. Doesn't matter. It just means that one is bigger than the other one. All right? Because as the guy is actually going up, it's becoming lighter.
Oh.
So the first one should come to the second, but that one they would penalize you. So even if you get a negative answer, write the answer as a positive. Make sense, Mohammed?
Yes, sir.
Yeah. As the guy goes up, it becomes what? Lighter, because the distance is increasing. Okay, lovely. Are we doing great?
Sir?
Yes?
Yeah, before we move on, I remembered I had a question, right? So about the negative, like you see, if we're doing work, energy, and power, and then we get a negative work, should we specify that it's opposite direction of motion or write it as negative?
Now once you say opposite direction, you are turning work into a vector, but work is a scalar.
A scalar.
So if you get, let's say you get negative 200 joules,
Mhm.
right? Write that, okay, W equals to negative 200. Now, in your next line, then you write W equals to 200 joules, open bracket, negative work.
Okay, negative work. Okay, thank you.
Yes, not direction, because it's a scalar quantity.
Okay, thank you.
All right. Okay, guys. Define electric field at a point. I taught you this the last time, and I remember specifying. What is the answer? At a point. At first.
Space.
That is when they say electric field.
Oh, yes.
Field, the region around an object where electrostatic force is experienced. The space. around an object or a charged object where electrostatic force is experienced. That is the electric field, open space. But when I say electric field at a point, I am referring to what? The force experienced per unit what? Charge. Okay. Draw an electric field pattern for two identical positive. All right. That's just a kidney diagram. It's a kidney. I call it a kidney diagram. Like, I did a bit of life science everywhere. I'm a multi. Huh? No, I can't. I don't have the brains for medicine. I wish. Oh, is it positive? Yeah, I'm right. No, I'd rather become a pilot. I'm registering for piloting school soon. See ya. Yeah.
What were you talking to the retro?
Just want to fly, bucket list. Fly. No, I don't want something fast. I want the real deal.
No, I mean like it's
easier. It's easier. That's what I don't want. I want to crash. Okay, but yeah. Anyway, let's quickly look at 10.3. We still have quite some work to do, but we're moving. Hey, we're moving. We're moving. Let's see. Wait, hold on. Okay. I saw some that I added. Okay, but anyway, let's move. Now, negative 30 microcoulomb point charge Q1 is placed at a distance 0.15 from positive 45, blah, 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 blah. The net electric field at point P is 0. I've already read all of those things. Okay. Calculate the distance, what? X. I'm sure we can do this.
Yeah.
Where do we draw the three-body diagram? At P. And we know they didn't mention anything. P is positive, right? So let's go there. Let's start with Q1. Q1 is negative. It's pulling P. So if it's pulling P, I'm going to do that, right? And the examiner is talking about electric field. So can I say EQ1? Now, what's happened to Q2 and P? Both positive. So this one should be moving in that direction. What do you have? E, Q what? 2. Let's choose right as positive, left as negative. The rest now is a matter of what? Substitution. But I now come here and say E net is, let's start with the positive one. EQ2 minus what? EQ1. Does that make sense to us? But they told us it's what? 0. So EQ2 minus, can I move the EQ1 over? So what do I have? EQ1 equals to what? EQ2. Are we on the same page? Now, what is the formula for E? KQ2 over what? R squared equals to what? KQ1 over what? Make sense? What is Q2? 45 times 10 to the power what? Negative 6. Now, what is the distance between? Oh, I actually love something here. I was hoping out. Beautiful. 0, what? 1, 5 plus x. All what? Squared. Equals to. What is Q1? 30 times 10 to the power what? Negative 6 over what? X squared. Do you remember what I did earlier on? I swapped it. Okay, so learn that principle quickly. I'll take my x squared up. What do I have? X squared. You said I using that calculator. X, check. What would that give me? 30 times 10 to the power negative 6 over what? 45. That goes. Instantly, find the square root of both sides. What do you have? X, it removes the square root there. Over what? 0.15 plus x equals to the square root of what? 30 over, what is 30 over 45 again? 3 over 2. Or you found the square root already?
No.
We need to now, so we're okay. What's the square root of that? Root?
So 30 over 45 is 2 over 3.
Sorry?
30 over 45 is 2 over 3.
Yeah.
This guy gave me 3 over 2. Okay, I believed him blindly. Rubbish. Okay. So what do we have? Okay. So x over 0.15 plus x equals to what? You have root 6 over what? Guys, I think you can do the math here. What do we have? Cross multiply, right? 3x equals to 1.5. What would that give you? But guys, I'm sure you can do the x.
Yeah.
Guys, are we okay here? We can do the x from here, right? Okay. The physics.
That's why you have to buy a Wi-Fi, because you don't get a mark for any of this. They just do it that for the substitution answer.
Okay. I just enjoy working it out. All right, beautiful. But the whole idea, oh Lord. Okay. Michelle, this is you.
Yes, sir.
But it's beautiful. Let us perform an experiment to determine the EMF and the internal resistance of a battery using the circuit below. The learners use this one. The examiner actually gave it right. They gave us the equation. We just need to rearrange the equation. But come, let's see. What is the equation? R equals to what? E over I minus what? R. Make sense? Lovely. Now, which variable has to be kept what? Constant in this experiment. Temperature is always something to be kept what? Constant. Write down the value of the internal. Guys, before you even start, let's break this down. What's on the Y? Resistance. What's on the X? 1 over I. So let's go and write, what's our equation? R equals to what? E over what? I. What? Minus what? R. Remember, what do I have here? I have 1 over what? I. And what do I have here? R. Do you see my y-axis already? That's fine. So let's extract that out. What are we going to have? I have 1 over I, right? So let's take it out. E into 1 over what? I. Y equals to what? Mx plus C. Do you notice what we have done? The gradient is my EMF. And the y-intercept is my what? Internal resistance. Now let's go check. What's my internal resistance? What's the y-intercept? I know you don't like this. I'll read it for you. It's 10. 1, 2, 3. Okay, let me use a red pen. So that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's negative what? 3. That's 6. Now check how it's going to play out. My y-intercept is negative 3. You notice that the negative will cancel each other. So what is R? 3 ohms. Beautiful. Calculate the EMF. I'm looking for the gradient. Gradient. Come, let's get the gradient. Oh, but guys, I think you can do the gradient, right? Can I move?
It would be a straightforward gradient, right?
No games, because my M is E. So whatever I get is my E. Are we okay? Michelle, you okay with this? Because this was your question.
Yes, sir. I'm okay.
All right. So,
No, yeah,
huh?
yes, I understand.
Okay, beautiful. Yeah, we did this, but let's walk through again quickly. Very interesting. I love this one. It's always a joker for me. This is a combination of work energy and power and circuits. Interesting. A battery with a an EMF of 12 volts and an internal resistance of what? 0,2. I think I'm done with the full paper. The number of questions I've done today now. All right. A battery with an EMF of 12, internal resistance of 0,2 are connected in series with a very small electric motor. Now, the idea is not that we've done it, is how do you approach? That I think that's more important to me than just solving, because you will be the one solving. Okay. Now, they told us that the resistor T is unknown. The motor is X watt. That tells me about the power. 3 volts and operates an optimal what condition. When switch S is closed, the motor lifts 0,3 kg vertically what upward at constant speed of what 0,4. There's already somebody's confusing, but is this not the circuit? Why is there meters per second? You see, it's very, very tricky there. Assume there's no energy conversion into heat and sound. Calculate the value of what? X. What is X again?
Power.
Power. What do I know? Okay, X is the power of the motor. You know, the first thing that comes to your mind is all the formulas of electricity of power. But then you would notice you are getting to a roadblock all the time because there's no current and there's no voltage. So we get stuck. But hold on. This is power. Okay, why are they bringing this in? First thing I'll remember is, wait, that is velocity. Oh, but power is F times V. We don't know F. Now I am going to draw a free body diagram. So I have gravitational force here, and I have a force what? Applied. Because it is moving at constant speed, acceleration is what? 0. It means that my F net is what? 0. And that means my force applied, which is this, is equal to the force of what? Gravity, which is mg. And why are you helping me? And that gives me power. All right. Miss. Okay. Now, guys, can we quickly calculate the force applied? This fly is helping me teach. Okay, making dots. Okay, what is my force applied going to be? Do we have the mass?
Yes.
0,35 times 9,8. What's your answer? 3,43 what? Newtons. Now I can get my power, which is X now is what? 3,43. What is my constant speed? 0,4. What's your answer? 37 watts. So that's the tricky part of this. Very interesting. The examiner is a very thoughtful examiner. Very tricky because you'll get stuck. That's okay. I don't have current. Then you'll be forcing. You know? And I love Leonard. Leonard will just say T is 1. You know? All right. Now, calculate the resistance of T. Do I now know my power? 1, what? And these guys are connected in series. Okay. We're looking for resistance there, right? What do you think we should do? What do we know? Oh, don't forget, you see, the idea of writing things on the diagram is very important. I have already missed that 3 volts.
Oh, yes.
And the next step writes on that. So sometimes we get lost in the words. So 3 what? Do you notice I have power? I can get my current now. So please, let's extract information from. Otherwise, you'll be stuck there. And then you realize later that, I've wasted 15 minutes trying to figure out. Okay. All right. So from here, power equals to what? IV. Am I right? What is my power? 1,37. I multiplied by what? What is the current in this circuit? Lovely. So if I have my current as 0.46, don't forget, it is the same current that goes through here. It's the same current that goes through here. Now, from here, there are different ways of calculating. You know what I will do? Just get lost volts. I want to just show you something. That's one way, but I don't want to go that way. I think it's long. Guys, what is your lost volt? I think it's long.
0.2 times 0.6.
Lost volt is I multiplied by what? R. What is my I? 0.46. Okay. And I want to do this also to just explain some concept of circuit. What will this give you? 0.92. Now, guys, don't round up here because I'm in the middle of the calculation now. 0.092 volts, right? Now, do you notice now that please, I wanted to check something here. I'm going to say something here. The lost volt, the 3 volts, and the volt here should give me 12. Why? Series are potential what? All of them are in series. They divide this 12. So can I then say the voltage in the VT will be what? 12 minus the one in the internal minus 3 volts. Does that make sense? Because everything should give me what? 12. Give me an answer. Sorry? 10,538 volts. Now I know that V equals to what? IR. Do I know the voltage? 10,538. Do I know the current there? 0.46 multiplied by what? R of T. What's your answer?
So
Yes?
I got the voltage as 8,908.
Yeah, I'm getting the same thing.
Okay. Thanks to Shamil. Shamil, why are we getting wrong answers? 10, what?
8,908.
Yeah.
And then what do I have here? 8,9. And because I'm tired, I'm not thinking. Just accepting your answers. What do we do? Divide by 0.46. What are we getting?
17,60. Oh, no, so that's 7.
19,
19,
36,
36 or 37?
7.
All right, are we on the same page? On the same page, everybody? Can I get an answer to this multiple choice? Multiple choice. This is my own question. Huh? You sure? Yes, let the answers pop in, please.
So for the previous one, we just took the EMF minus the
All the other voltages.
get the voltage of that one.
Yeah.
Calculate what it is.
So how's your circuit now?
That's good.
For myself, what a whole lot of toys today.
She has money to waste. Yes. Okay, I've got a B from Kian. Let's see. Okay, I have a B from Mohammed. I have a B Cosray. Well, okay, all of you are going for B. People here are going for D. Okay. Is it about location? If you're at home, you choose a B. If you are here, you choose a D.
Definitely.
I wonder what you do if you are in the car. Okay, wait. They said XY. They said XY is what? Wavelength, right? Huh? Am I right? Transition from X to Y is wavelength. What are we looking for?
The wavelength
From X to Z.
from Y to Z is twice the energy.
Okay, wait. Let's read again. I didn't read. The energy difference between X and Y is twice the energy. The energy difference between Y and Z is twice the energy between what? X and Y. So if this is E, can we call this 2E? Okay. So the wavelength of the photon transition between X to Y, okay, is that. So what is the, let me show you how to do this without guessing, because we're guessing between B and D, B and D, B and D. Okay, this is what I would do if I don't want to guess. What is my formula? E equals to what? HF. HC over lambda. Okay, so between X, let's work between X and Y. E equals to what? HC over what? Lambda. Standard. Now, between X and Z, let's call this, so between X and Z, what do I have? 3E. Right? So 3E is what? HC over, I'm looking for this lambda, let's call it lambda XZ. So let's look for lambda SZ. Wait, what is E, by the way? Okay, to make this clear, let's call this lambda what? XY. Now let's change E. What do you have? 3 HC lambda what? XY. Does that make sense? Equals to what? HC over what? Lambda what? YZ. So that everybody would see what's going on. Look, you can cross multiply, you can divide, but this HC would cancel each other. But let's make it simple for everyone. Let's cross multiply. 3 lambda YZ HC, because that's what I'm looking for, is equal to what? Lambda XY HC. Lambda YZ will be equal to what? Lambda XY over what? 3. So the correct answer is D. And also you must remember that they are inversely what? Proportional. That's, if you actually remember that, you'll be done. That the longer the wavelength, the smaller the energy. Did that make sense to everybody? Are we okay? All right. That before final, so that we didn't have time. There's going to be 2 hours of just multiple choice. We're doing nothing. Just multiple choice. I think I have a video like that. That it should be somewhere there. Have you ever done this question before? This is mine. Yeah, that's the joke in the question. But let's walk through. I would have loved to say, okay, guys, try. But yeah, isn't me being over ambitious? I added mine. but not bad. Yeah. Oh Lord.
Yeah, so we don't get into it.
Oh my. Oh my. Oh my.
No, we didn't do much about this in
Huh?
about this.
We did. Okay, but guys, this is my question. Do you have questions that I didn't? Okay, there's this one, work energy and power. Okay, the main thing here, guys, okay, let's run through. So a constant force F applied at an angle of 20 degrees above the horizontal pulls a 200 kilogram block over a distance of what? 3 meters on a rough surface. The coefficient of friction is what? 0.2. Give a reason why coefficient of friction has no unit. We answered that question today. Ratio of forces. Please, 5.2. State work energy theorem and work. The net work done on an object equal to its change in kinetic, and just change that formula. Do you remember that formula? Work energy. It means there's work on one side, there's energy on the other side. And this is the formula. Work net is equal to, change that into words. The net work done is equal to the change in kinetic what? Energy. 2 marks. Done. Draw a free body diagram indicating all the forces acting on the block while it is being pulled. Let's quickly draw. Can you see the diagram? Please draw. No, this marks I want you to get. 4 marks. Please draw. Draw, and let's work from there. Those of you watching from YouTube, are we okay? I'm not seeing any of your comments. It means you are following. Anybody who wants to study again tonight, I mean, this video can actually be very, just need to put it on ×2. Because you guys say I talk very slow.
Good night.
Yes, that's why I want just go and sleep. I'm going to sleep. I'm not even marking today. I miss my bed. All right, are we done? What's your free body diagram looking like, everybody? It's a dot. What are we drawing? The normal force of gravity. Thank you. Force applied in that direction, right? Where? Friction is opposite what? The direction of motion. So what do? We label force of what? Yeah.
Friction is a contact force.
Friction is a?
Contact.
Yeah. Yes, it is. It is, because it must be in contact. That's why your non-conservative forces are all contact forces.
So
Friction, applied, and tension.
you know when they ask you those theory questions, and you label friction as a contact force, like yeah, because it's lifting it more off the ground, so you say it's making less contact, therefore less friction. Or that
No, but we're not lifting off the ground, yeah? We're dragging.
yeah, but it's at an angle to where it is kind of lifting up.
No, it's not at all.
It's still lifting up, but it's going to be making less contact.
No, it's not making less contact. It's not. The force is in that direction, but the object is still being dragged.
Yeah. But then force of friction is decreased.
It remains the same. It remains the same. That's why they told you. Because if I want to calculate friction, it's mu kn, which is mu k mg cos theta or cos alpha. So it's not changing. The only time friction will reduce is if we are told that the object is now lifted, which reduces the contact. That's where you're going.
Yeah.
So if we are now told that this is now lifted, such that the object is now like this, then friction would decrease because of the number of contacts are also what? Decrease. That's why your towing vehicles will always do that and lift up. But here, it's like you are dragging something that is on the ground. Imagine you're dragging something very heavy, and the only way is just to drag. You can't lift it. That's what's going on. All right. Okay, guys. Do you think you can do 5.4? It's just 4 marks. Try, please. Can you try for 3 minutes? Show that the work done by frictional force. Let's put a timer because we don't have all day and all night. Oh, yeah, it's fine. We've covered everything. That's okay. Even if it's here. I added a bit of 20 seconds because I'm kind. Oratile, you can't be telling me now BPM. The instruction was send me the questions that you are struggling with. You cannot now type BPM in here. You didn't send me any BPM question, child. I told you I'm not going to look for questions. Okay, guys, were you able to get this?
No.
What a guan. Give me your responses quickly. So I chose a good question. Were you able to get this? Thumbs up, thumbs down. Your way. Okay, what's wrong, guys? The thing is, guys, the same principle that you've been doing is what you should do. Don't change principles. No, you didn't. I promise. I promise you didn't. Look at what I would have done. Since I'm looking for work done by what?
Oh, sir, you
Okay, let me see. What do I have? I have that, right? Check. I have that. I have that. And I have this. Work done by what? What is this? What's applied, right? What is this? Friction, right? FG and normal. We are looking for work done by friction. And what's the work done by friction? It is basically frictional force delta X. That's all. But the question is, what is frictional force? Frictional force is what? Mu K N. What is N? Can you see the progression of the question? What is N? I cannot deal with N until I resolve this. So let's quickly resolve. What do I have? I have my normal force there. Now why am I having a green? I have my normal force. I have my what? Friction. I have my FG. What's going to happen to this applied? It's going to go left and up. So what is this? Fx, Fy, normal, Fg, and friction. Same page? Okay, where's my angle? 20. So my angle is right here. If I were to complete this diagram, what is the one that is, this is Fy, right? Fy will be sine. So this is what? F sine what? Theta. Okay, we use theta. Now, what is my N? How many forces are pointing up? 2. How many down? 1. So it means N plus Fy equals to what? Fg. What is N? Fg minus Fy, which is what? Mg minus F sine what? Theta. That normal should come here for me to get friction. No, Fy.
Okay.
So what is now my frictional force? Let's quickly get friction. Friction is what? Mu K N. Right? Already we have N, right? What is my mu? 0, 2. What is the mass? 200. Or let's get a value for this thing here. This is 200 times what? 9,8 minus F. What is the angle? Do we have the angle? 20. Okay. What does this give us? 1,960. Are we okay? 1, 2. Yeah. So let's bring that in here. 19 what? 60 minus F sine what? 20. Let's multiply. 382, 392. Right? Minus what? 0,2 F sine what? 20. That is my frictional force. But what am I looking for? I'm looking for work done. I'm going back to the beginning. What is my work done formula? Fk delta X cos what? Theta. What is my Fk? 392 minus 0,2 F sine what? 20. What is our delta x? 3. Cos what? 180. What is cos 180? Negative 1. Negative 1 times 3? Negative 3. What is negative 3 times 3? 92. Now that negative 3 multiplied by 0, 2, negative 0, 6. How did they ask us to leave the answer? Oh, positive. All right, what is 0, 6 sine 20? 0, 6 sine 20. Because we're changing all of that. 0, you want it as 205.
Yeah, 205.
All right, done.
I just want to give up Pokemon.
Why? It's the same process that we've been talking about, right?
So after that, so tell the lady that the domestic
All the things I got wrong, so I just complain about it.
Okay.
I don't need to say those things.
That everything wrong, everything after that now went down. Guys, are we okay? Come, let's run. Let's run. Are we okay? What's what? All right. Oh yeah, to the Department of Education, but dealing treacherously with you with ABSISA. They should give us money from ABSA.
Nothing just bad. I got all of paper.
But it wasn't bad at the end of the day. Anyway, guys, I think for 5.5 you will be able to do that. It says calculate the magnitude of F that has to be applied so that the net work done by all forces on the block is what? 0.
That's where you substitute the frictional one.
So the question is, what forces are acting? It's just 2 of them.
Friction and
Fx and friction. Done. So if we want our F net to be 0, what will it be? We are saying F net is Fx minus. Please, where's my minus coming from? Negative and positive. And that should be equal to what? 0. I'm not going to solve this whole thing. Can I move that over there? The frictional force must be equal to what? Fx. Do you remember what it was? Negative 1176 plus 205 what? F? Sorry. 0, 205. All right. And what is this? F cos. Cos what? 20. I'm sure you can get F now. Move that over to the other side. It's just met now, or met clips. You know. Okay, so guys, I think the main thing was this other question that you needed to analyze. Please look at your N. N is always a problem. I don't know why they called it normal force. I would have called it's not normal at all. I would have called it abnormal because it changes based on whatever situation. And the key is your free body diagram. I don't know if we are on the same page now with this. And
the N finance.
oh, immediate. There's an immediate word there.
Yeah.
Immediately. So it's 61 there. Okay, you still analyzing? Okay, we're good. All right. Okay, this was my question. Michelle sent me this question. There's an error in this question. 2.3 was an error, I think.
Yeah, from 2.2.3.
Yeah, there was
to the bottom.
yeah, there's an error in it. Okay, so don't stress much about this question.
Okay, thank you.
Yeah, but I'll work it out. I just want to see something quickly here. I want to see something here quickly. A teacher demonstrates how current can be obtained by using a bar magnet. coil and the galvanometer. The teacher moves the bar magnet up and down as shown. That's electromagnetic what? Induction. Briefly describe how the magnet must be moved in order to obtain a large deflection. What would you do? Move. Now, the reason I chose, I think, I don't know, somebody sent this question and I quickly saw interest in it. Now, if you say move the, which is what most learners did, I remember, I think I was marking this particular year. Most learners were saying move the magnet faster. Fine, you're okay, you're right. But you are not telling us where. Now, even if you say relative to the coil, if I move here, it's still relative to the coil. I need to move in and out of the coil. You need to mention that. Move faster in and out. So you might think you've answered by saying move faster, but you get a 0. It's move 0. Move fast. Wait, am I not moving?
I know, but now come on. Then why they gave it to them first?
Huh?
You obviously know you must put the movie.
Yeah.
Oh, no. Yes, that's why it's physics.
You can pass it right.
Move in and out. So
Why
when
have to move faster? We have to get
Get
out
out.
of the point.
Huh?
There's arrows if you can get out of first.
Great. Look at this. Am I not moving? According to the arrows.
Yeah.
Because it assumes that it's obvious that you're moving it.
Okay, now nothing is obvious in physics now. So please, we're very specific, right? So let's learn that. We need specificity there. Okay. What is this? Electromagnetic induction. That's the principle. We mentioned that. Write down part X. Ah! Now, don't write split ring, remember? It must be split ring commutator. Or you can just use the word commutator. If you write split ring alone, 0. Yeah, you're allowed to just say commutator. It's fine. Okay.
Understand some. This is like some. Yeah, it is just substitution.
Okay. It's basically substitution, right? Because we have the, okay, I won't do all of it. I want to do one. I think I put one vertical there, and there's one work that I saw that they have to find an angle, 7 marks. Yeah, so I want us to do that. A 220 volt AC is supplied from a wall socket. Please take note. Sometimes they don't give you this last statement. So this examiner is just being kind. Wall sockets provide what? RMS. So sometimes they don't. Give you that.
Always RMS.
Yes, always RMS. So what do we know? We know the voltage, but it's voltage what? RMS, 220. What do we know? Resistance, 40, what? 33. Calculate what? Electrical energy consumed. We are looking for E, which is the same thing as what? Work. We've done that today. Per second. People don't look at that. T is 1. So look for the appropriate formula. I think we can use what? E or W equals to what? V. That works. Do I know my resistance? Yes. Do I know my time? Yes. Do I know VRMS? Yes, with that. Maximum current. Maximum current. What do you now know? We can use V equals to what? I multiplied by what? R. But this is RMS. This is also what? RMS. And then I can do this. What is IRMS? I max over root 2. Oh, why did I say equals to R? Times what?
The information they give you in the question is the RMS.
No, they'll tell you. They'll tell you whether it's
maximum or RMS.
it will always be, they won't hide it from you. Look at this one. I just love this diagram. Okay, generators. The diagram below shows the different position A, B, C, D of the coil in a DC what? Generator for complete revolution. The coil is rotated clockwise at a constant speed in a uniform Write down the energy conversion that takes place in a DC generator. The keyword is the generator. Mechanical to electrical. You are producing electricity with the generator. Okay? Sketch a graph now. That's the one that caught me the most. At A, what are we generating? 0. When the coil is standing vertically like that in between the fields, we're generating what? 0. And it's a DC, right? So what will it be? Do you remember a DC? A DC is a frog jump.
Yeah.
But we're starting at what? 0. So that is A, B maximum, C 0, D again, maximum, and A back to what? 0. Am I right there? Yeah. Very, very important. And then you label your Y and your X. What's our Y? EMF. And this is what? Time. Okay, let's begin look at this, and I'll go and look at that 7 marks question on work and 1 vertical projectile motion, just to clarify something there. A small AC generator providing an RMS voltage of 25 volts is connected across a resistance of what? 20 ohms. There's something lovely in this question. The wires connecting the generator to a device has a total resistance of what? 0. Do you know in circuit they tell you to ignore the resistance of the wire, but now they're telling the wire has what? A resistance of 0.5. Write down the total resistance of the circuit. 20? Why 21? The total resistance of the circuit, 20.5. Because the wire is 0.5. And the device is what? 20. So that's very, very key. 20. Why did you say 21? Are we okay with that 20.5, guys? Because of the resistance of the wires. Calculate what? The average power. What are we looking for? P. And what is P average? P average equals to what? I RMS multiplied by what? V. Oh, but let's see what we have first. What do we know? You see, they tell us RMS voltage. So we have V RMS as what? 25 volts. Is that clear? What are we looking for again? Average power delivered to the device. What do we know? Okay. Now, if this is 25, do you notice that these things are connected? If this is producing 25 volts, what do you think will happen? Can we get the IRMS? Yeah, we can get the IRMS, the total current in the circuit. We can by using V equals to what? IR. Okay, so total current V equals to what? IR, but RMS, right? What is my VRMS? 25. What is I? We don't know. What is the resistance? So that's the secret. The 20.5 is where things are just hiding. So you get the I what? RMS. Now you can take that back into what? Are we okay? Guys, are we okay there? So the yes.
So why can't we use P average is equal to V square RMS over R?
You can.
So will our R value be
20.5.
Oh, 20.5 ohms?
Yes.
Okay.
All right. So the key was just that 0.5 of the wires. That was the main key there. You have to add it because most of the questions we do are always saying ignore the resistance of the wire. So in case you see that. All right. I don't know. Do you guys remember this? A cold gas, absorption spectrum. Hot gas, emission spectrum. So please take note. When I see a cold, so please mind that the cold gas is absorption. Oh, here. And this one is what? Emission spectrum. Okay. I don't want to stay long on this. Let's go back to this question quickly. So I'm not going to, I won't be able to do all of this. I tried, guys. I tried. So look at this one. Interesting. Now, why are you pushing your head down? You see, now after this, you just need to get a good rest, you know.
So it's so definitely good.
But that one is audio because I've been crying about those definitions ever since the beginning of the year. That one has nothing to do with me. All right. A 5 kilogram block is released from rest. Okay, let's start. Released from rest. Initial velocity here is 0. A height of 5 meters slides down a frictionless, right? To a point P as shown in the diagram below. It then moves along another what? Frictionless horizontal portion PQ, and finally moves on a what? Second one. Can I do that just to? All right, friction. Okay. It comes to that at 3 meters. The frictional force, which is a non-conservative force between the surface and that is what? 18 newtons. Okay, we're good. We read. Use energy principles. Calculate the speed of what? I taught you what to do here. At P, it's an isolated system, right? Please just use work done by what? Huh? I use this one. I don't want stress. And because it's isolated, this is automatically what? 0. Yes. This is actually mechanical energy at the top. This is mechanical, but since I put a 0 here, it will. I actually proved it one day like that, where I proved mechanical energy at the top is mechanical equals. Yeah, I did. So this is half what? M BF squared minus BI squared plus M G what? H final minus H initial. Do I know the M? Talk to me. 5. We are looking for what? BF squared. Do I know the initial? 0. Plus 5, 9,8. What's the final height? 0. And what's the initial height? Do you see straightforward? Straightforward, quite easy. Just remember, if it's isolated, the work done by non-conservative is 0. We good? Answer? Use your wife's calculator. Get me an answer now. Okay, now 9,9. Okay, thank you. 9,9 meters per second. Good done. Explain why the kinetic energy at P is the same as the kinetic energy at P.
It's frictionless motion.
It's frictionless and horizontal. Because what will two things that will make the kinetic energy reduce is friction and the height. If there's a height, because we are now converting what? Kinetic to potential, but the height is 0. So 2 points there. Number 1, frictionless and horizontal. Frictionless and huh? There's one there. No, there's one. I think there's one where they even talk about. Let me see. Okay. But I'll see. Extend the time. No, leave me alone. 5.4. Calculate the angle. Yeah, that one is on you. Calculate the angle theta. What would you do? So hold on. That's 9,9, right? This one also comes and becomes what? 9,9. I would use WNC. Okay, and we know it comes to a stop. Come, let's do it together. I'd love us to quickly do it together just to enjoy the flow. Work done by what? Non-conservative equals to what? Change in kinetic plus change in what? What are your non-conservative forces? There. Which one is present? Friction. So this is work done by what? friction equals to what? Half m df squared minus vi squared plus mg h final minus what? H initial. This is what? Friction delta x cos theta, right? Okay. Okay, I'm going to rewrite this, by the way. Plus mg h final. Let's do the substitution together. What's our friction? 18. What's our displacement? Okay, we don't know it. We can simply use the theorem of Pythagoras because I then know that sine theta is opposite over what? Hypotenuse there. 3 over what? Sine theta. But let's see, can I work without? Okay, let's leave it. I'll tell you what. Let's work on something. Let's leave it for now. Yes, I'll solve for x and take it back into that. Makes sense? Yes. What is the mass? 5. What's the final velocity? 0. We got 9,9 there. Plus 5, 9,8. Now, what is the final height? It gets to the top at R. 3 minus 0. Guys, I'm sure you can get delta x from here, right? Then I'll go back to what? Sine theta equals to what? 3 over delta x. And with that. Guys, you do that tomorrow. The idea is to. Yeah, you can. You can bring that in and work with it. Did it make sense? Did it make sense? Did anybody try this question? Have you ever done this question before? It's a nice one if you understand what's going on. Okay, let me take you through. There's something just a bit tricky there. Okay, let's run through quickly. Ball A is projected vertically upward at a velocity of 16 meters per second from the ground. Ignore the effect of air resistance. Use the ground as 0. Calculate the time taken for the ball to return to the ground. You know what I would do? I would say the ball went up and came down. So if I choose upward as positive, my initial velocity is 16. My final velocity is negative 16. And since I'm choosing up as positive, my G is always acting down. Negative what? 9,8. I have VF, I have VI, I have A. I'm looking for time. VF equals to what? VI plus A what? Delta T. What's my VF? Negative 16. 16 minus 9,8 delta T. Please get me that time. Never. You can't get that time as negative. Because you're going to be what? Negative 3,27 what? Seconds. 4 marks. Sketch the what? Velocity time graph. Again, for velocity time graph, just write all your velocities. I think I've taught you how to simplify that thing. 0 here. What velocity do I need? I need a positive 16. What is 3,27 divided by 2? 1,65. 63. That's the time. It's halfway. And I'm done with my graph. Very straightforward. And what is that time there? 3,27 what? Seconds. Okay. That was just the main point is this. 1 second after ball A is projected, a second ball B. Now, 1 second, very important. Okay. Yeah. So ball B is thrown vertically downwards. Now thrown at a speed of velocity of what? 9 from the balcony, 30 meters above the ground. Refer to the height below. Calculate how high how high above the ground ball A would be at the instant the two balls pass each other. First thing, it's not half.
Then it wouldn't be 6 now.
Please, it's not. If it's half, then it's just 15 meters, and then we are done. It's not halfway. How do we quickly analyze this, guys? We won't take long on this. Probably the last one I'm finished. Okay, look at this. It's 30 meters, right? Which one was going up? A was going up at what? 16 meters per second. All right. Now, and B moving what? Down at 9. So they actually cross each other at a particular point. I don't know what that point is. Halfway. But I know that ball A has gone delta YA. And ball B has gone delta YB. Can I say, please let's go step by step together and make sure you agree with me that no, don't worry, we'll get there. The distance of A plus the distance of B is 30. Does that make sense? If I'm using distance, that's going to be my principal. Now let's go find delta Y of A. By the way, ball B was thrown 1 second later. That means if A travels T, this will be what? T minus 1. Travels 1 second shorter. I have my initial velocity, and I have my time, and I have my displacement. There's a formula that brings the three of them. Now for A, delta Y equals to what? BI delta T plus half A. So the delta Y of A, what's the initial of A? Oh, we're choosing up as positive, right? Remember? So this is what? 16 what? T plus half negative 9,8 what? T squared. Let's simplify. 16T minus 4,9, but this is the delta Y of A. Now, what is the delta Y of B? We use the same formula. Now, this is where it's going to go south a little bit. Not really, but there's something. What is the initial velocity? Negative 9. That's where it starts going south. You see, that's what makes it go, because we're choosing upward as positive. And the time is what? T minus 1 plus half. We keep our A, guys. And T minus 1 what? Squared. Now, what is the delta Y of B? Are you aware that this is 30 minus the delta Y of A? We agree?
So it's not delta Y minus the minus delta Y.
You know, I'm going to change it. So, guys, are we agreeing that this is 30?
Yeah.
This is delta Y of A, if we subtract. However, this guy is coming where? We chose upward as. So what should this one be? Negative 30 minus delta Y of A.
So is that the same thing as delta Y minus?
Yes. That is where it goes down. You see those two,
It's already, yeah.
those two negatives is where the rest,
This is starting from the top.
because we chose upward as positive. Downward arc, everything going down except time. The rest is yes, talk to me. The rest is just math. Yes, talk to
So
me.
could we equate the two and solve for y because they're saying where it passes, the height that it passes. So won't it have the same height?
We can just equate now, right? Huh?
Could we equate before the 30 minus delta y?
And if you are equating, you must make sure you put that negative there. The problem is the negative.
Okay.
Yeah, that's why I first have to explain that negative is the problem. If you do 30 minus y without the negative, we're gonna run into issues. Guys, I think here you can win. You have to spell binomial here. No, guys, I'm not doing that. Not really. You will end up with a trinomial, but it's going to cancel out. Because check here, by the time I do this,
Oh, that's right. The negative.
negative 4,90, because I am bringing this guy here now, 16t minus 4,90 squared. The 4,90 squared will cancel out, and then you get your time. So it's just basic. But what I wanted to just emphasize is the direction, the negative 9 and the negative what? 30 minus delta y. Guys, are we okay? Are we okay, everybody? Huh?
No, so it's the total distance is 30 and the distance of A is the delta, the delta y. You can subtract that too, but because it's after it's positive, that's why it's negative.
So always write your direction. Very, very important. Okay, hold on. 5 minutes. Let's finish. Do we need to do this? It's very long, but we can do it in 5 minutes. In an excited, 5 minutes. I promise not more than 5. In an excited atom, electrons can jump from lower energy levels to what? They can also drop. The diagram below, not drawn to scale, shows that they are dropping, right? Is this an absorption or an emission spectrum? Emission, because for it to emit, it has to lose. So when it loses, it drops. So this is what? Emission. This is a free mark that I need us to get. Guys, I'm not going to do all the whole jargons, but here is what I want to show you. Calculate the frequency of the photon produced when an electron in an excited state moves from what? E4 to E2. So the energy, because we want photon, right? E equals to what? H, F. H is a constant. What I need is what? E, because I'm looking for frequency. But from E4 to E2, what would I say? E4 minus E2 equals to HF. You can finish the rest. So I said that my 2,04 minus 1,6, that's that.
So this is the changing.
That's the energy lost. And then you can calculate the frequency. All right. I'm sure, guys, we can also calculate kinetic energy by using which formula? Top line. Equals to work function plus what? Kinetic. I know you are tired. That's what you said. I need to use that old formula. All right. It says calculate the kinetic energy of the most energetic electron when the photon produced in 11.2.2. So we will have gotten our E there, right? And we know the threshold what? Frequency. So, yes, so our E4 minus our E2, no, H, F naught, plus half, you're just talking nonsense now. Okay, after this page, I'm not going further. That's my E, right? Why am I bringing HF naught? Because they gave me threshold what? Frequency as 4,4. So everything is already done. I know that constant. I know that constant. What am I looking for again? I'm looking for what? Maximum. Oh, I don't need to break it down. I'm looking for maximum kinetic what? Energy. So I can just leave that. Yes, if they want velocity, then I'll have to open it up and say half mv squared, and I'll do mass of an electron. Guys, I hope this activity session has been able to help a little bit. You know, I almost answered all the questions. But yeah, I tried. Yeah. What? What? When is he finishing? Eh, Good job. Guys, good night. Please take time to rest, but most importantly, those definitions must be in place. Each question has its own definition. Please. And you guys, you can predict the definitions. So go for those ones first. I can predict for you. Yeah.
I'm gonna just learn it.
I'll predict for you. I'll send you I'll type it out and I'll type it on WhatsApp. I'll do a voice note. But it's important just to know the whole thing per topic. Good night, everybody. Those my YouTube lovers. Good night. Enjoy your exam. Good luck, everybody. And you can go over it again. Bye.
I'm coming with your piece tomorrow.